see we're asked to solve this oxidation reduction reaction, but it's a little bit different than before. Here we actually have to solve it in basic solution. So remember, in basic solution there's two things that are abundant, OH minus and water. So you're going to do this exactly the same as before, but this time whatever, the same procedure and the same pipeline, but whatever H plus you add to balance the half reactions, you're going to neutralize that with an equivalent amount of OH minus. So this problem here will serve to illustrate that phenomenon. You're going to do everything as before. So what we have here is MnO4 minus going to MnO2. So let's go ahead and write this half reaction out. Let's go ahead and balance the oxygens. I have two oxygens here. So in base, recognize we have OH minus plentifully, as well as water plentifully. So now I'm balancing my oxygens. I'll balance my manganese, Mn. And now we have an issue here where we have 8 oxygens on our reactant side and 4 oxygens on our product side. So I'm going to use water here to balance out my oxygens. But now I have 8 hydrogens. I've introduced the hydrogens. So I'm going to balance that with 8 H pluses here. And recognizing that I am in OH minus, so the same procedure as before, as if it's in an acidic solution, but now it's really not in an acidic solution, it's in a basic solution. So for however many 8 H pluses I add to balance my hydrogens, I will add an equivalent amount of hydroxides. So adding 8 OH minuses here, whatever I add on the left-hand side in terms of OH minuses, I have to add it to the right-hand side. And now what we need to do is just balance the charge. Okay? So balancing the charge, 8 minus 8 plus 8 is 0, minus 2 here. Here I have minus 8. Okay? So to balance this in terms of charges, so this is charge 0, this is minus 2, this is minus 8. So minus 2, if I add 6e minus here, minus 6 minus 2 is minus 8, and here's minus 8. Okay, this 8 OH minus cancels out with the 8 H plus. All right, so we're going to do everything, or what we did was everything is the same as before, but for every H plus we add an equivalent amount of OH minus, hydroxide ion. We can do that because this is what we have a lot of. And then whatever I add to this side, I have to add the same amount to the other side. So 8OH minus plus 8H plus, remember we can have no H pluses here because this is in basic solution. So this is actually 8H2O. And the 8H2O, 4 of those will cancel out with 4 of these. And now we should have our half reaction. This is a reduction half reaction because we gain 6 electrons in order for MnO4 minus to go to MnO2. So our final half reaction here is going to be 6 electrons plus 4 H2O plus 2 MnO4 minus. And that's going to go to 2 MnO2 plus 8 OH minus. So notice that there is no H pluses. I cleared them because the problem tells us this is in basic solution. All right, so our next half reaction is going to be Cn minus going to Cn minus going to CnO minus. So here is our second half reaction. So the Cn is balanced. The carbons and the nitrogens are balanced. I have a lone oxygen here, so I'm going to balance that with water. So I have water. All of this is happening in water. So one oxygen. I'm going to balance the hydrogens with 2 H pluses. Realizing that it's in base and I can't have H pluses, so I'm going to neutralize that with OH minus. Whatever I do to this side of the equation, I have to do to the other side of the equation. And now it's just a matter of balancing the charge. So balancing the charge here, this is minus 2 minus 1 is minus 3, and this is minus. So here, if I put 2 E minuses on the product side of the ledger, I will balance my charge. So minus 2 minus 1 is minus 3. Plus 2 minus 2 cancel each other out. Minus 1 minus 2 is minus 3. So minus 3 here, minus 3 here. This 2H plus 2OH minus is 2H2O. One of those H2Os cancels out with this H2O, leaving one left behind on the product side. And now I have everything for this part of my half reaction. This is 2-hydroxide plus Cn minus is going to go to CnO minus plus water plus 2E minus. Okay? This is a oxidation half reaction because we lost 2 electrons. Let's go ahead and rewrite our reduction half reaction, the one where we gained 6 electrons. So we need to balance out the electrons here. To do that, I will multiply the top half by 3. And multiplying the top half by 3, this gives us 6OH minus plus 3Cn minus. That's called the cyanide ion. That goes to 3CnO plus 3 waters plus 6 electrons. So let's rewrite this and cancel out our electrons, and hopefully everything is balanced from then on. Okay, so balancing this equation by canceling out the electrons. And let's see if anything else cancels out here. You see here the 6 OH minuses will cancel out with this, leaving me with 2 OH minus. And here 3 waters will actually cancel out here, leaving 1 water here. So I am getting as my final answer 3Cn minus plus H2O plus 2MnO4 minus. And that's going to go to 3CnO plus 2MnO2. And then there's a 2-hydroxide left over. Our final check, let's make sure everything is balanced, both charge and atoms. So we have 3Cn here, 3Cn, we have 3Cn here. We have 2Mn here, we have 2Mn here, so far so good. Hydrogens, we have 2 hydrogens here, we have 2 hydrogens here. The oxygens may be a little bit tough here. 2 times 4 is 8. 8 plus 1 is 9 oxygens. Here we have 3 oxygens, 4 oxygens, and then 2 oxygens, so 9 oxygens. Now finally we have to balance the charge. And if we balance the charge, we're good. So this is minus 3, and this is minus 2 for a total of minus 5. Here we have a minus 3. Here we have a minus 2 for a total of minus 5. Yeah. So this is the correct balanced equation in basic solutions.